Before entering the topic, first we will discuss about what is called multiplier and what is called booth multiplier. So generally multiplier is very much important for all the signal processing application. So if you want to make a multiply for 2 bits names, so we need a multiplier. So the operation for the multiplier is it will make the multiplication of multiplicand and multiplier. So next we are going to discuss about booth multiplier. So booth algorithm is a very powerful algorithm for signed number multiplication, that is a positive as well as negative number multiplication. So which treats both the positive and negative numbers uniformly, and it will generate 2 power n bit of products, that is for the input for the response of the input it will make generate of 2 power n bit of product, and it is worked through the modified booth algorithm, and this will reduce the multiplier bits. The major disadvantages of Radix 2 algorithm was that the process required n shift and an average of n by 2 addition for an n bit multiplier. So this variable number of shift and odd operation is inconvenient for design the parallel multiplier. So that is why the Radix 4 modified booth algorithm is invented. So here all the limitations of Radix 2 algorithm will be reduced. So for operands equal to or greater than 16 bits, the modified Radix 4 booth algorithm has been widely used. It is based on the encoding of 2 complements multiplier in order to reduce the number of partial products to be added to n by 2. So here I just figure it out the booth multiplier architecture. So we have 2 inputs, that is multiplicand and multiplier. So the multiplicand is given to the 2's complement generator, and the multiplier is given to the booth encoder. So from that the partial products is generated with the help of the partial product generator, and finally the generated partial products will be added with the help of carry look ahead adder. So this is what the entire structure of booth multiplier, and it is completely worked based on the booth's algorithm. So next we are going to discuss about the booth algorithm. So in the booth algorithm we are having 2 type of algorithm is there, that is Radix 2 algorithm and Radix 4 algorithm. So Radix 2 means we just group the multiplier bits by 2 bits, and Radix 4 algorithm means we just group the multiplier bits by 3 bits. So that is what the major difference between the Radix 2 and Radix 4. So here I just mentioned the table called booth recoding table for Radix 2 algorithm. So I am just mentioning the multiplier bits, that is the before applying the booth algorithm, and if you apply the Radix 2 algorithm means what will be the multiplier value. So that is what mentioning as a multiplier value, that is MR. Okay, so see here the I minus 1 and I bit. Okay, if it is 0 0 means the multiplier value will be 0, and if it is 0 1 means the multiplier value is minus 1, and if it is 1 0 means the multiplier value is plus 1, and if it is 1 1 means the multiplier value is 0. Let me clarify the things. You can see. So first we are going to take the multiplier bit as 1 1 1 1 0 0 0 1 1. Okay, so now we are going to reduce these multiplier bits with the help of Radix 2 algorithm. Okay, so before starting to the reduction, so initially you have to add a 0 in the LSB, that is least significant bit. We are going to add a 0, so that is mentioned as a red color. Okay, so once you add a 0 in the LSB, so next we are going to apply the Radix 2 algorithm, that is with the help of the above table. Okay, so now from the LSB we are grouping the bits by 2 bits. For example, so the first group is 0 and 1, and the second group is 1 and 1, and the third one 0 0, and the fourth one 0 0, and the fifth one 0 1, and sixth one 1 1, and next one 1 1, and the final one is 1 1. Okay, so now with the help of the above table we are going to mentioning the output multiplier bits. For example, 0 1, the first grouping first group of bit is 0 1. So if it is 0 1 means what will be the multiplier value? It is minus 1. So that is why I am just mentioning minus 1 in the top of the 0 1 group. So next group is what? 1 1. So 1 1 means what will be the multiplier value? That is 0. So that is why I am just mentioning under 1 1 as 0. Okay, so likewise you have to make a reduction of multiplier, that is actual multiplier bit, with the help of Radix 2 Booth algorithm. Okay, I hope you understand. So next we are going to see an example. In the left side I am just mentioning the Booth algorithm, that is 0 0 means we have to put 0, and 0 1 means -1, and 1 0 means +1, and 1 1 means 0. Okay, so now I am going to make a multiplication of +13 and -6. So initially itself we have discussed so Booth multiplier, by the help of Booth multiplier we can make a multiplication of signed numbers, that is negative numbers also we can take it. Okay, so that we already discussed in the introduction itself. Okay, now we are going to take a example, that is multiplicand value is +13 and the multiplier value is -6. So before entering to the binary multiplication, so before itself we are make the multiplication as a decimal point of view, that is +13 and -6 is equal to -78. So we need the result called -78, okay, for this inputs. Okay, so let's proceed to the process. So +13 so initially I am just mentioning the binary value. So for the +13 I am just mentioning 1101, and for the +6 I am just mentioning 0110. But definitely you will ask one question, my multiplier value is -6, so now we are going to convert the -6 into +6. So that means what is the process to convert the negative value into positive value? So we have to take a 2's complement. Okay, that is the process to convert the negative value into positive value. So you can see, so for -6 you have to take a 2's complement of +6. So that means, so what is the value of +6? 0110. So first you have to take a 1's complement, that is 1001. So next you have to add 1 with the 1's complement result. So that means the -6 2's complement result is 1010. So now we have the +13 as 1101 and the -6 as 1010. Okay, so now we are going to proceed for the multiplication. So before proceeding to the multiplication, so we have to add a sign bit in the MSB. So that is why here I am just to add 0 to the +13 and 1 to the -6. So because if we are going to add a sign bit means, so if it is a positive number now we are going to add a 0, and if it is a negative number now we are going to add 1, right? So next we are going to reduce the multiplier bits. So that is what Booth algorithm. Okay, so we are going to reduce the -6. So for the -6 I am just writing the bit value, that is 11010. So before itself I told, okay, before going for the reduction you have to add a 0 in the LSB. So that is why I am just adding a 0. So next you have to make a group of 2 bits. So by the help of Booth algorithm I am just reducing the multiplier value from 11010 to 0 -1 +1 -1 0. Now I am just to make a multiplication of +13 and -6. So the multiplication process is very similar. Okay, so after the multiplication you are going to add the partial products with the help of adder. Okay, so finally I am having the -78. You can see the result is 11100010. So that means it is a -78. So the MSB bit is 1 means what now? So it is a sign bit. Okay, so this is what the process of Radix 2 process of Booth multiplier. So the same thing is explained here. Whatever I told it in the previous section, so the same thing is explained in a theoretical manner in this slide. And next we are going to discuss about the Radix 4 multiplier. So since I already told what is the major difference between the Radix 2 and Radix 4 means, Radix 2 means we are having we are going to group 2 bits, but here we are going to group 3 bits. So that is why in the table input we are having 3 bits, that is I+1, I minus 1, and the multiplier value as output. So that is 000 means it contains 0, and 001 means +1, and 010 means +1, 011 means +2, and 100 means -2, 101 means -1, 110 means -1, and 111 means 0. Okay, so again the same process now. Okay, so before going for the processor, you have to add a 0 in the LSB, then you have to make a 3 bit as a group, and with the help of the above table, we have to reduce the multiplier bits. Okay, next here is the example for the Radix 4 multiplier process. So here I am going to make a multiplication of minus 11 into plus 27. That is, multiplicand value was a minus 11 and multiplier value was plus 27. So since I already told you, if it is a minus number means we have to take a 2's complement. So that process is done initially, and after that the multiplier value will be reduced with the help of Radix 4 algorithm, that is I minus 1, I plus 1, I minus 1. So that means what is the output? So here I am just listed, and finally with the help of Radix 4, the multiplier bit value is reduced as a plus 2, minus 1 and minus 1, and then the normal multiplication, and from that there is a generation of partial products, and finally the partial product is added with the help of adder. Okay, so since we have result that is minus 11 into 27 is equal to minus 297, so that exact answer is there in the Radix 4 process, that is 1110 1101 0111, that is what minus 297. So this is what the process of Radix 4 booth multiplier, and the same whatever I told it in the previous example, the same thing is explained in a theoretical manner here. Thank you. So that's all about booth multiplier. Thank you all.